extension of those points what we have already talked about, like averages, different rules, or deviation method, or weighted average. In mixture, what happens, you have, let's say for an example, a rice of one variety is mixed with the rice of, let's say, second variety. Now, the first variety is of certain quantity and certain price. The second variety, maybe let's say a premium one, is of, there are certain quantity and then it's having a higher price. If both the varieties are mixed together, generally that's what the nature of the question will be. If both the varieties are mixed together, I need to find out what is the average price of this mixture. Now, in a situation of this kind, what we should not be doing, but before that, let's take some numbers so that we can understand through those numbers. So, rice of variety 1, rice of variety 2. The quantity and the second one is the price, which is rupees per kg. That's how, which we represent, and quantity in terms of kg. Now this is, let's say 10 kg and this one is 40 kg. R2, let's say it's a premium brand. Now 10, this is assumed, let's say this is 20 rupees per kg. And this one is maybe, let's say 50 rupees per kg. Now I'm mixing the two brands of rice. And then I need to find out what is the average price. What we should not be doing. We should not be simply adding up these two numbers. 20 plus 50 divided by 2, 70 by 2, 35 rupees per kg, which is a blunder. That's a mistake. We saw this idea in the earlier concept also, weighted average. So now we can take this mixtures as an extension of the concept which we have in weighted average. These are like the weights which we have, weights which are assigned. Now this is 40 and this one is 10. So well, one understanding is if I take, let's say 20 plus 50 by 2, I get 35. Intuitively I can say that because my numbers are different, my answer cannot be equal to 35. Now will it be less than 35 or will it be more than 35? The way we decide that is going to be governed by what numbers are over here. I can see that my number, the weightage is more towards this number. That means my answer will shift towards this 50. That means my answer for the average will be more than this 35. How much more? To get to the exact value, that's what we can apply any of the plenty different methods which are there. Method number 1. In method number 1, let's call it as M1. To find out the average price, again back to the basic idea. Average, we know that is equal to total. This is simply total divided by number of items, or depends like what exactly we are talking about. It could be number of items or it could be the quantity. Now here, the total amount, the total cost of this R1 is 200, method number 1. Total cost of this brand, R2 brand, is 40 into 50. That makes it as 2000 divided by total quantity, which is 10 plus 40, which is 50. So further thereafter, just adding up these two numbers, we can see that this is 2200 divided by 50. And finally, it turns out to be 44 rupees per kg. Clearly, it has to be more than 35 rupees per kg. Now, that's what is method number 1. Method number 2. In method number 2, we assume some average price and preferably take up a number which matches with one of these two numbers, maybe 20 or maybe 50. Any of these numbers we can take up. For example, I take up this number, let's say this is 20. 20 plus. Now thereafter, the calculation procedure. This is anyway 0, the difference, deviation method, as the name itself suggests, the difference is what we have to take. 50 is more than 20 by 30. Now please note that this 30 what we get, we will simply not be writing 30 here. This 30 must be multiplied with its weightage, and its weightage is 40. That is, there are 40 kg here. So 30 is multiplied with 40. We get what number? 1200. And this sum is divided by the total quantity. And here in this scenario represents the total quantity. Total quantity is 50. 1200 by 50, which is back to 24 plus 20. Obviously, we'll get the same answer, which is 44. While these are the two methods which are there, we'll also have a quick look at the third approach, the third method for answering such question. Now, in this context, it's recommended that maybe you can refer to that, the earlier module, what we talked about this weighted average, because this idea in this mixtures is similar to what we have taken up in that weighted average. Now, in the third approach, what we deal with, it's an extension of this method number 2. gone by the deviation principle. Here also we will be going by deviation principle. But that's a critical point here. This number 10 and 40, these numbers do not play any role. What matters is the ratio of these numbers. The ratio of these numbers play a role. 10 and 40, the ratio is 1:4. So we can say that if I want to find out the average price of this mixture, then I don't have to necessarily bother about 10 and 40. It's the ratio which really matters. So this situation is similar, exactly similar to a scenario like this. Let's say if I take two different brands, R1 and R2. For the first brand, I'll take 1 kg. And for the second brand, I'm going to take 4 kg. Now, why should we be taking the ratio? Because it helps in simplifying the numbers. For the calculation purpose, it becomes very easy. Coming back to those numbers, we will retain these numbers, 20 and 50. We will not tamper with these numbers. Then, the answer which you get here is going to be the same answer as what we have been arriving earlier on. So, let's continue with that. So, 20, let's say this is what is now we are dealing with this method 3. And in this method 3, assume any average, maybe let's say this is 20 is the average or 50 is the average. We can take any of these two numbers. Plus thereafter, the last part, this 20 is not more, not less, 0 is the gap. Plus this 50 is more than 20 by how much? 30. But this time 30 is not multiplied with 40. If I keep 4 here, I'll have to multiply with 4. So 30 into 4 is 120. This divided by the sum total of these two numbers, not the sum total of these two numbers. So sum total of 1 and 4, that turns out to be 5. So we divide by 5. So at least some part we can see that the calculation gets minimized, and this becomes especially very useful if I have very clumsy looking numbers. So once this is done, we are back to that same answer, which is 24 plus 20, which makes it as 44. So that's the simpler example which we have taken up here in the context of this averages. Now, to generalize that, I can have a situation where let's say this is Q1, this is Q2, this is P1 and this one is P2. So if I have to find out the average price, we'll say that my average price as a generalization can be represented like this. So it could be in terms of the price quantity, it could be in terms of maybe marks, the number of students and so on. In all such cases, when we are dealing with, I have two different, let's say, products. Maybe let's say A is one of the product, B is the another product here. I'm dealing with the quantity which is there in terms of the kg as the previous example what we have been dealing with in terms of the numbers. Now let's take up a more generalized situation, the price which is there in rupees per kg. Now here let us say that this is Q1, this one is Q2, price here is P1 and this one is P2. So what do we do to find out the average price? For the average price, we can say that this P is equal to P1 Q1 plus P2 Q2 divided by sum total of the quantity. This fundamentally is what we have as an idea behind the mixture. But it's obviously a start to, there are so many other issues which are there, which are involved in terms of what happens when we take up the solutions and so on. What happens when we have to really solve some, let's say, very difficult set of the question. How can we apply and extend this idea? But before we solve such questions, a very, very important idea here, which is about in the context with alligation. And this principle of alligation, once we complete that, then we'll see the task becomes a lot much more easier in the process of arriving at the answer for any such difficult looking nature question. So friends, let's look at this about the concept alligation. Quite an interesting one. Lot of questions which otherwise become very difficult to solve by the conventional methods become very easy to solve for using this principle of alligation. But what is it about? Let's take something where we ended with. In fact, the previous module you would have seen that about the mixtures. In mixtures, when we are talking about for let's say 2 or 3 or maybe multiple categories, multiple varieties of let's say any product, maybe rice, and we need to find out what is the average price of this entire mixture, well, we come across with a result something like this. Though this is about for 2 different varieties, it could be extended for maybe 3 or 4 or n number of such varieties as well. Alligation, what it does, it tries to segregate. Now here, you can see that on the right hand side, I have the price, I have the quantity, everything is packed together. In allegation, the basic rule what happens, it segregates. On right hand side, you will be having, let's say, maybe the quantity. The left hand side will be totally about the price, or vice versa. On one side, you have the only about the quantity. On the other side, just everything about the price. So this segregation really makes things so easy in terms of arriving at the answer for majority of the question. Now what we do here, first of all, let's segregate that. How we do that? Cross multiply. We get P times Q1 plus P times Q2. And this is equal to, on the right hand side, we can see that P1 Q1 plus P2 Q2. Again, putting the numbers and the different variables which we have over here on one side, we get this Q1 multiplied by P minus P1. On the right hand side, what we get is this Q2 multiplied by P2 minus P. Then taking the ratio further, Q1 by Q2. This is equal to P2 minus P divided by P minus P1. Now, you might be having this question at the back of your mind. What is it really which is happening here? How does it really matter if I put that particular thing in this particular format or maybe in this particular format? No issues. That one or this one, they both are same. There is no difference. But then from the point of view of solving the question, we'll see the difference here. We'll come to that, but for the time being, what exactly the point over here is this. Now, left hand side, we can see only quantity. Right hand side, we can see about the price, P2, P1, everything is about the price. Many a times you'll see that this entire thing can be represented in the form of a diagram. And when we want to put in the form of the diagram, that's what really happens. For any variety, let's say this is what is price P1. We take the second variety, which is P2. Now, what is the average? We never say that the average is going to be P1 plus P2 by 2. That's what we have seen earlier on as well. What is the average? This is P. Thereafter, in the diagrammatic form, what you have to do, take the difference. Difference you take in any order. It could be P1 minus P or maybe P minus P, but any order, you choose that. Well, I'm going to choose, let's say, maybe P minus P1. I have chosen this one. Now comes the other difference. The other difference, now look at it, this is P minus P1. The other difference automatically gets fixed. I cannot really take any order for the other difference, that gets automatically fixed. If this I am taking P minus P1, the other difference must be in the reverse order, that is P2 minus P. So we put this as P2 minus P. Then thereafter, we say that the last part in this, we come to a conclusion that over here, if I need to find out what is this ratio of these two, express these two variables, this ratio is same as the ratio of the price, is same as the ratio of the quantity. For this first variety, there is some quantity Q1. For the second variety, there is some quantity which is Q2. This is what is the internal set, the mechanics, what really happened. And finally, we can say that, look, Q1 by Q2 is P2 minus P is 2, P minus P1. So this diagrammatic format really helps us a lot in terms of visualizing as to what we have kept it over here, which otherwise maybe one would have to really remember or maybe memorize. So now, how do we make use of this? We'll take a few examples, quite interesting one as far as the application part is concerned. And friends, please note that this is not just confined to a situation of quantity and price. Quantity and price is one context. It's just one context. I can have many such contexts over there. For example, I can take up a situation where this is the number of persons. Let's say this is the number of males, this is the number of females. And then this is about the average age. Or this could be the average weight. Or this could be the average height. It could be anything. So, let's see those examples, those questions, and we'll see that how this allegation really makes things so comfortable for us.